Hello friends, welcome to Shiksharthi. In this video, we shall be solving questions of exercise 7.1 on coordinate geometry. So let's start. Talking about question number 1, it talks about find the distance between the following pair of points. Okay, so now there are two formulas which we'll be using throughout. One of the formula is the slope formula. So if I say the slope between any two points lying on a line will be y2 minus y1 and x2 minus x1. So the division of this y2 minus y1 divided by x2 minus x1, which is the rate of change of ordinate divided by the rate of change of abscissa. Similarly, we can find out the distance between any two points, and then we note the section formula also. So section formula says if I have to ascertain the value of x is just like saying m1 times of x2 plus m2 times of x1 divided by m1 plus m2, and the same for y. So these are few formulas that we will be using throughout our discussion. So question number 1 basically asks us to find out the distance between 2 points, and the 2 points which they have given here are 2, 3. So it is subdivided. So question number 1 is subdivided into 3 parts. So the first part says 2, 3 and 4, 1. So you are supposed to find out the distance between 2 points. Let's assume these 2 points are A and B. So can I put it like this now? The distance between A and B is under root of x2 minus x1, which is 4 minus 2 whole square, plus 1 minus 3 whole square, which is just like saying under root of, now 2 whole square is 4 plus another 2 square is 4, so which is under root of 8, which can be written as 2 root 2 units. Similarly, talking about subpart 2, the distance, you have to find the distance between minus 5, 7. So let's say this is A and this is B, minus 5, 7 and minus 3, 1. Let me just check the values once again. It is minus 1, 3. So applying the same logic here. Now x2 minus x1. So now I am not writing this, I am saving time now. So minus 1 minus of minus 5 becomes plus 5. So this becomes minus 4 whole square plus 3 minus 7, which is again minus 4 whole square. So this comes out to be a root 32. And a root 32 I know is 16 into 2. Now 16 under root is 4. So 4 root 2. Remember, the distance can never be negative. I mean, the measure of a distance. Distance is you are measuring something. So the measuring unit of a distance wherein you are measuring something cannot be negative. Now finally you have to find out the distance between A, B. So let me take 2 points as x, y, wherein the coordinates of x are A, B, and the coordinates of y are minus A, minus B. In this case, if I have to find out the distance between x and y, this will be nothing but under root of, now minus of minus A, which becomes minus 2A whole square, plus minus of minus B. So this becomes minus 2B whole square. Can we write it as this is 4 times of under root of 4 times of A square plus B square, which can be further written as twice of under root of A square plus B square. Okay, moving on to question number 2. So question number 2 says find the distance between points 0, 0 and 36, 15. So you'll be applying the same formula. So let us say the 2 points here are x, y. This is 0, 0 and this is 36, 15. So applying the formula, you will be able to say that the distance between x and y is equal to root of 36 square plus root of 15 square. Under root of 36 square plus 15 square. Now how much is 36 square? Okay, how much is 35 square? So 35 square, if I have to calculate a 36 square, I can just do it right away, though I know the answer, but 9 followed by a 24 followed by a 36. So no, 9 followed by a 36 followed by a 36. So this comes out to be a 1296. Now how am I able to do this so fast? For that you can watch my video on calculations, wherein you can master accuracy and speed when it comes to calculations like anything once you watch the videos. Okay, so now in this case this comes out to be a 1296 and plus another 225, which comes out to be how much? So if I take it as it is, so let's say if I would have taken this as 24, let's say this would have been a 204, and this is, so if I add 204 to this, how much do I get? 1500. I would have taken only 204, so this is 1521. Now can I say under root of 1521 is 39? So using the same formula that I had used here, 3 square is a 9, so 9 into 3 is 27 into 2 is 54, and then 9 square is an 81. So which gives me the answer as 15, the under root of 1521 is 39. I hope you understood this. Talking about the latter part of this question, it says, can you now find the distance between the 2 points A and B discussed in section 7.2? So please mind it, whatever solutions that we are talking about here, we are basically talking about the basic and the best way of solving the questions. So there, as per us, there are two ways. As per me, there are two ways of solving any question. There is one is the basic way and the other is the best way of solving the question. The best way comes out of the practice that you would subject a basic way to. So whichever, so the solution set that we are talking about here is, we are subscribing to all those methods that we would have discussed in our training videos, the videos that we would have talked about in terms of the basics and concepts of this topic, which is coordinate geometry. So we are using the same concepts as discussed in the videos. Moving on to question number 3, it says, if the points these are collinear, determine the points. So you know the condition for collinearity as talked about in the videos. So let's assume that these points are collinear. This is how you start. So let's say the points are A, B, C, wherein the coordinates of A are 1, 5, followed by 2, 3, followed by minus 2, minus 11. So if these 3 points are collinear, so can we say that slope of AC will be the same as the slope, the slope of AB will be the same as the slope of BC, which is the same as saying that as the slope of AC. Let's see this first. So what is the slope of AB? So the slope of AB is y2 minus y1, which is just like saying 3 minus 5 divided by 2 minus 1, which is minus 2. Similarly, if I find out the slope of BC, it's just like saying y2 minus y1, which is minus 14 divided by x2 minus x1, which is minus 4. This comes out to be a how much? You need not go further now, because once these slopes are not equal, the slope of this will not be equal. So are they collinear? No, they are not. Moving on to question number 4. Okay. Question number 4 says, check whether these vertices are the vertices of an isosceles triangle. Okay. So let's take the vertices as A, which is 1, 5, the 5, minus 2, and the other vertex, let me take it as B, which is 6, 4, and the third vertex, let me take it as C, which is 7, minus 2. Now what is the definition of an isosceles triangle? An isosceles triangle, the definition is either you do it in terms of angles or you define an isosceles triangle in terms of the length of the sides. So you know that for an isosceles triangle, any two sides, if any two sides of a triangle are equal, but the third side is unequal, then it becomes an isosceles triangle. Similarly, when any two given angles, any two vertex angles of a side are equal. If I talk about this is an isosceles triangle, and if I say these two angles are equal, but these two angles are not equal to the third angle, then also we are able to say it is an isosceles triangle. So this gives me a hint that I can do it by either slopes or I can do it by the distance formula. So I can use either of them. Let's first try it out with the help of the distance formula, which says, can I find out the length of the line segment AB? Okay, which is x2 minus x1, which is 1 square, which is 1, plus y2 minus y1, which is 6 square, which is 36. So this comes out to be a root 37. Now, if I find out the distance AC, the length of the line segment AC, can I say this is nothing but x2 minus x1, which is 2 square, which is a 4, plus minus 2 plus 2. So we are finding out the distance. So 7 minus of 5 is 2, with 2 square is 4, minus 2 and plus 2 becomes 0. So this becomes 2. Similarly, can I find out the distance of the line segment, I mean the length of the line segment BC? Yes, I can. And the length of the line segment BC is how much? Minus 2 minus 4, which is minus 6 whole square, which is 36, plus 7 minus 6 whole square, which is root 37. Is it an isosceles? Yes. This is using the distance formula. Now let me use the slope formula. What is the slope for AB? The slope for AB is y2 minus y1, which is 6, divided by x2 minus x1, which is 1. Similarly, the slope of BC is nothing but y2 minus y1, which is minus 6, y2 minus y1, which is minus 6, okay, and then divided by x2 minus x1, which is 1. Now the slope of the third side, which is AC, which is y2 minus y1, which is 0, y2 minus y1, 0, and this becomes what? x2 minus x1, which is non-zero. So this means the third side that we are talking about, the triangle, that becomes the x-axis. Now, can we infer that since these two slopes are equal? Why can we infer? Because when we are using the slope concept, use what? Take only the measure, not the polarity. Take only the measure, not the polarity, because here, now if I say this is an isosceles triangle, which I am saying yes, it is an isosceles triangle, and I am saying that these two angles are equal, and we are talking about this is A, this is B, and this is C. So as we have talked about in our videos, so can I say this slope is positive? So in that case, if this slope is positive, this cannot be C, this has to be B. And similarly, this slope is negative. Why is it negative? Refer to the videos. So now we will not say that because this is plus 6 and this is minus 6, henceforth our their slopes equal. Their slopes are equal because we are not concerned about the polarity, and we are concerned about the magnitude talking about this question. Moving on to question number 5. So question number 5 talks about, in a classroom 4 friends are seated at the points A, B, C, D as shown in the figure 7.8. Okay. Let us refer to the figure. Don't you think ABCD is a square? Now thinking will not help. We need to apply some properties of a square. And even before we apply the properties, let us basically talk about the coordinates of A, B, C, D. Let us first talk about the coordinates. So let us find out the coordinates. So let's find out the coordinates for A first. So can I say it is 3, 4? For B, the coordinates are 6, 7. For C, the coordinates are, let's say 9, 4. And for D, the coordinates are 6, 1. And we are talking about x, y. So we are determining the coordinates in terms of abscissa, comma, the ordinate. So for D it is 6, 1. And what are we supposed to ascertain? We are supposed to ascertain, the first is, don't you think ABCD is a square? Thinking will not help, we'll have to find it out. Next, Chameli disagrees. Using distance formula, find which of them is correct. Now when you are using the distance formula, you are using only the distance formula. So when you are using the distance formula, one should understand that the distance formula merely does not help you to uniquely identify whether it is a square or it is a rhombus, because in the rhombus also all the four sides are equal. So I require one more additional condition to differentiate between a square and the rhombus, given that the initial level of similarity between a square and a rhombus is that all the four sides, if they are equal, that does not necessarily mean that it is either a square or it is a rhombus. It can be one out of the two. But then Chameli disagrees is using the distance formula as a metric to measure. So in that case, if I have to find out the length of the side AB and then the length of the side BC followed by the length of the side CD, so AB, BC, CD, and the final length here is DA. Let us try and find this out, because this is the first condition which will say whether it is a square or not. This is the first condition. The second condition is all the vertex angles should be equal to a 90 degrees. Okay, so using the distance formula, can I say this is nothing but 3 square plus a 3 square, which is just like saying 9 plus 9, which is 18. So can I say this is a 3 root 2? Yes. BC, so again it is just like saying 3 square plus 3 square, which is 3 root 2. Again when I say CD, 3 square plus another minus 3 square does not make any difference. Minus 3 square is equal to a 3 square only. So can I say this is also 3 root 2? Yes. Finally, can I say that, okay, talking about DA, this is also a 3 square? Yes. Now, Chameli would agree that this is a square only using the distance formula. And Chameli disagrees using distance formula. Find which of them is correct. Champa, Chameli, wow. Okay. So if I say using this, and then if I say that using the distance formula, can I say that this is a square? For a square, all the four sides should be equal. So is it correct from Champa's perspective? Because Champa says, don't you think that is a square? Yes, it is a square. But to complete this perspective, because as we discussed earlier, distance is not the only rubric or a matrix or a metric to find out whether this is a square or not. The additional parameter here is you need to find out the slopes of all these lines. So for example, the slope of two lines which are perpendicular to each other. If you recall, we have discussed this in a certain sense in our videos. So if I say the line, so let me draw a square here. So if I'm drawing a square here, and if this is A, this is B, this is C, and this is D, and I'm saying that these points, these are, so can I say that slope of this line into slope of this line should be equal to a -1? So I'm giving you one of the perspective here. So if there are two lines which are perpendicular to each other, the product of their slopes will be equal to a -1. What is the slope of the line AB? Is just like saying 7 minus 4 divided by 6 minus 3, which is 1. Slope of the line BC is just like saying 4 minus 7 divided by 9 minus 3, which is -1. So is this correct? Yes, it is. And why should I waste my time on other values? Because if I'm getting a let's say a parallelogram in which one vertex angle is equal to a 90 degrees, in which one vertex angle is equal to a 90 degrees and all the sides are equal to each other, can I say that the resulting figure would be a square? Yes. Because we know that it can be one among a square or a rhombus. A rhombus will never have any of the vertex angles equal to a 90 degrees. So why should I waste my time in finding out? So is this a square? Yes. Chameli disagrees, but she is incorrect. In that case, if she is incorrect, who is correct here? Champa.